Hello everyone. So in today's lesson we're going to continue with exponents. We're going to learn about what we call the exponent laws. Really all they are is just a set of rules that we can use that allow us to evaluate things a little bit more efficiently so that we don't always have to jump to our calculator right away. Um, Before we do that, we just have to make sure you're a little bit clear on some terminology. So I've written out here a power and what it is equal to. So what I want to highlight here is just a reminder that that 3 is actually called the exponent, that this 2 is called the base, and I'm going to use a different color here. The whole thing together, that is what is called the power. So we have a base of 2, an exponent of 3, and that whole thing makes up the power. So when we use some of that language through the lesson, you'll understand what we're talking about. So the first thing I want to do is look at what happens if we're multiplying powers that have the same base. So in my example, they both have a base of 5. And what I'm going to do to develop this rule is I'm just going to write this out and say, well, what does this really mean? So 5 squared really means that we want to do 5 multiplied by 5. And then we're going to multiply. And we're going to multiply by 5 to the exponent 4, which really just means we're multiplying here by 5 4 more times. So there's the first power, 5 squared, and there's the second power, 5 to the exponent 4. But since this is all multiplying, if we count this all up, what we'll see is that we're actually multiplying a whole bunch of 5s. It just happens that we are now multiplying 1, 2, 3, 4, 5, 6 of them together. So what we want to look at is there an easy way that we can get from here to here so I don't have to jump to my calculator right away? And hopefully when you do that, we can see that to do this, what we did is we took these two exponents and we just added them together. And then once we do that, so this I could do very quickly without a calculator. And it saves me then some time when I'm doing this on my calculator to be efficient. Now I could just do 5 to the exponent 6 and let it do the big calculation. And then we end up with 15,625. So the idea here is that when we are multiplying these powers, we can then add the exponents and keep the same base. And notice that as we did this, we didn't do anything to that base 5. It was still a whole bunch of 5s that were multiplied together. So we kept that the same, but we added those two exponents together to do that. So now, without the extra step in the explaining, what we can do is if I had a question like this, instead of having to type this all into my calculator, what I would do is I could first simplify. So I leave that base number as 3. I can take the two exponents and add them together. In this case, we get 6. And then I can come to my calculator and say 3 to the exponent 6 equals 729. And it's just a little bit more efficient way of doing this. Same thing here. I could simplify. I leave that base number the same. It's a negative. That's fine. And I can then add the exponents very quickly. 2 plus 6 gives me an exponent of 8. And then I can come to my calculator. And if you remember from the last lesson, I said those brackets are important. So I'm going to make sure I type those in there. I have a base of negative 2. And I'm going to use the brackets to the exponent 8 equals, and it tells me my answer is 256. So there's our first rule. And we have 3 rules that we will look at. So the first is if we are multiplying. The second rule is what happens if we are dividing powers that have the same base. So in this example, I've used division as a fraction. I'm going to do the same thing I did up here, which is to say, okay, let's write this out. So I have 5 times 5 times 5 times 5 times 5. Okay, 5 to the exponent 5. So that means we multiply 5 times. And I'm dividing that by 5 squared. So 5 times 5. As we divide here, what we can do is say, well, this will divide one of the 5s out from the numerator. This one will divide a second 5 out from the numerator. But you'll notice that we don't have any 5s left over. So if these are now all divided out, we are left with these 3. So I'm left with 5 to the exponent 3. And again, our goal is, well, how could have I got there from the beginning? And if we look at this here, what we should see is that if I have subtracted these exponents I would end up at that exact same spot. So we can subtract the exponents to get there. And then you can use your calculator. In this case, that exponent's small enough. I know this one is 125. So it allows me to quickly get to this here and then do a little bit of calculator work to get my final answer. So when dividing, we will subtract the exponents and keep the same base. So in this example, the base is 2, so I keep that same base. The exponents 7 and 4 I will subtract. I get exponent 3, and this one actually I know, again without my calculator, 2 times 2 times 2 will give me 8. So the idea of these rules is just to make this a little bit more efficient and quick to evaluate, so we don't have to jump to the calculator so quickly. We can also do this with this division sign. It's the same rule, and we can do this with a fraction base as well. The idea is that we keep that base the same. In this case, our base number is that fraction in brackets, 2/3. And because I am dividing, I can subtract the exponents. 5 minus 2 will tell me that the exponent is 3. Remember, with a fraction base, what I can do is apply that exponent to both the numerator and the denominator. Okay, I'm going to write it out. You don't necessarily have to write that out. And then I can apply this exponent now and say that 2 times 2 times 2 is 8. 3 times 3 times 3 gives me 27, and there's our answer. So there's our first two rules. If I'm multiplying, I'm going to add the exponents together, keep that same base. If I'm dividing, I'm going to subtract the exponents, keep that same base. And then our third rule is what happens if we have, oh, I forgot to change this. This should say power of a power. So what happens if we have what we call a power of a power? A power of a power is when I have this power here, and then there's another exponent on the outside. So this first exponent inside says 5 squared, means I'm going to multiply 5 by itself. And now the second exponent out here is saying I'm going to take that and I'm going to multiply that 3 times. So if we do this 3 times and we count this up, we're just still all multiplying here, but really what we're doing is we're multiplying 1, 2, 3, 4, 5, 6 5s together. So writing it back as an exponent, I can say this is the same as taking 5 and multiplying it 6 times. Again, our goal is to say, well, could I have got there in one step? And again, we're looking at what are we doing with these exponents. So if I have 2 and 3, how could I get this exponent 6? Hopefully we realize here that we could then multiply the exponents. And if we do that, okay, we can then get to our answer quickly. Again, instead of trying to figure out how to type all that with the brackets into the calculator, we can just simply say, I can multiply those quickly, and then our calculator work becomes much easier. 5 to the exponent 6 equals, again, we get 15,625. So given what we call a power of a power, that's this scenario here, we multiply the exponents, and again, notice that we've kept that same base here. So without all the extra work, if we just apply this rule, here's our power of a power rule. I would keep the same base of 4. I would multiply the exponents together. 2 times 3 gives me 6. Okay, that I can do quickly, and then allows me again on my calculator to get my answer very quickly. 4 to the exponent 6 equals 4,096. The purpose is then if I have something like this, which could be very tedious or long to type into my calculator, I can actually do this now fairly quickly if I understand what those rules are. I have a couple rules that I'm going to apply. I'm going to start in the numerator. If I'm multiplying, I'm going to keep the same base, and I will add the exponents. That gives me 2 to the exponent 9. I'm going to leave that over 2 to the exponent 4. Now I'm dividing, so I can subtract the exponents. I get 2 to the exponent 5. So I can very quickly simplify this expression. Some of you might be able to go from here right to here all in one step. 6 plus 3 is 9. 9 minus 4 is 5. So it allows me to take this big expression and make it quite small quite quickly. Now a little bit of calculator work at the end. 2 to the exponent 5 equals, and we get our answer here, 32. So we can combine a number of these rules. Here I have our power of a power rule. So I'm going to take care of this part here first. I would have 3 and to the exponent. Power of power means I'm going to multiply these. 2 times 2 gives me 4. Multiplied by 3 to the exponent 3. I'm now multiplying powers. Again, we just leave that base number the same. And when I multiply, I'm going to add these two exponents together. So again, I get to this very, very quickly. And for some, again, you might be able to do that all in one step. And then if I evaluate this, 3 to the exponent 7, and we end up with our answer, 2,187. So the idea of these rules is that we can simplify the expression quickly with a little bit of mental math, because generally the exponent work when we're adding and subtracting or multiplying these numbers will be quite easy to do. And then we can use our calculator just to finish off the power after without then having to type all of this into the calculator and worry about typing in something wrong. For your homework, this is what I would like to see, is something like this here. The question is going to say simplify, then evaluate. So I would like you to simplify using our exponent laws first, and then use your calculator to get the final answer second. What I don't want is just one final answer where you're typing all of this or trying to type all this onto your calculator in one step. I would like to see this at least done in 2 steps, simplify and then an evaluate. And you might need one extra step here. We use 3 steps. If you have any questions, let me know. Send me an email, or you can ask for me to call you, or we can do a video conference if you're having difficulties.